Welcome to our channel. This lesson I want us to do a practical that involves solubility. Solubility is one of the analysis that is tested in kcse paper 3 and as a quantitative analysis. Okay, here with me are some apparatus. You are provided with the following apparatus and reagents. 1.6 gram of the oxalic acid in a stopped container. 1.6 gram of the oxalic acid in a stopped container. And that one, distilled water in a washing bottle. We are given distilled water in a washing bottle. And boiling tube. We have a boiling tube in test tube breaker. Thermometer. We have the thermometer, which is used to measure the temperature. We have the measuring cylinder of 10 ml. Measuring cylinder 10 ml. 10 ml measuring cylinder. Measuring cylinder. And basin burner. Basin burner. We have the basin burner. We have the mic box. Basin burner is a source of heat, and the mic box us to ignite the basin burner. We have the test tube holder. Test tube holder, so that I cannot directly hold or the boiling tube because it will burn me. Then I will use test tube holder. Test tube holder will assist me. Transfer all the solid into a dry boiling tube. Transfer all the solid into a dry boiling tube. After transferring all the solid into a dry boiling tube, here is my solid. Add 2 centimeters of distilled water. Add 2 centimeters of distilled water. Add 2 centimeters of distilled water. I'm adding 2 centimeters of distilled water. Warm the mixture until all the solid dissolves. I'm going to warm the mixture in the boiling tube until all the solid dissolves. I am going to warm the mixture until all the solid dissolves. I'm warming the solid until it dissolves. Yes, the solid dissolved. Now the solid dissolved. The solid dissolved. Then the solid dissolved. Now heat the mixture while stirring with the thermometer a temperature of about 60 now. So we heat up to a temperature of 60. Now it is even above this temperature of 60. So a temperature of 60. So lazima ikuwe a temperature of 60. Like that. I will drop it ikuwe a temperature of 60. From a temperature of 60, I will start now. Now it is a temperature of 60. Allow the solution to cool while stirring the thermometer. Allow the solution to cool. Allow it to cool while stirring the thermometer. There are so many ways of allowing. You can pour water on the boiling tube, on the surrounding of the boiling tube. So you are allowing now. Yes. Now I've allowed. Now note the temperature at which the crystals start to appear and record the temperature at this. Now crystals start appear. Crystals, are you seeing now crystals? Crystals appeared at a temperature of 50. So I'm going to write that. Crystals appeared at a temperature of 50. So I will come here now. Crystals appeared at a temperature of 50. So I will write the first one now. At the temperature of 50 now, 50 degrees Celsius, 50.0 degrees Celsius. So I have made the first one. Now I'm going to do the second procedure, the second now experiment. That is, know the temperature. Now I've noted, I've recorded in the table. Add 2 steamers of distilled water to the content of the boiling tube and heat while stirring until all the solid dissolves. Now they are saying add 2 steamers of what? Add 2 steamers of water again. Add 2 steamers of distilled water to the content of the what? To the content of the boiling tube. So this is the content of the boiling tube. Now I'm going to add. I've added. Now they are saying again, heat the solid while stirring until also dissolves. Now they are saying heat now again. Heat so that all the solid dissolves. Heat so that all the solid dissolve. Are you see now? All the solid dissolve. Good. Now, allow the mixture to cool and record the temperature at which the crystals first appear. Now again, allow the temperature to cool now. So, allow the temperature to cool. Now, allow the mixture to cool and record the temperature at which the crystals are going to form. As I told you, if you want to allow boil water or maybe put in a water bath, then allow it to cool. Yes. Are you see now? Are you see crystals started to form? Yes, that is now 40. That is 40 now. It is 40. Yes. Yeah, 40. At 40. That is 40. Then you come and write it here now. And you record it here, 40. 40.0. Good. Now we repeat the procedure 3 times and record the temperature in the table. So I'm going to repeat the procedure 3 times. So I'm going to add 2 steamed cubes of water to each. So this time I will add 2 steamed. Again I will heat or warm. Now when all the solid dissolves, then I will remove it. I will withdraw. Then I will cool it. Then I will write the temperature at which crystals form. I'm going like that. So let me measure again 2 steamed of water. Yes, 2 steamed of water. Yes, 2 steamed of water. Okay. Read it. Now again I'm going to what? I'm going to heat or warm it that all the solid dissolves. Now all the solid dissolved, all solid dissolved, all the solid dissolved, all the solid dissolved. When all the solid dissolve, then I will allow it to cool. I will allow it Yes. I'm going to allow it to cool so that crystals are forming. As you see, the crystals are forming. The sulfate dissolved are going to come back to form crystals. As you see now, after allowing it to cool. Yes. So that is the temperature. That is now 33 now. 33. At a temperature of 33, the salt started to form, the solution started to form. Slowly now. Good. Again, I will do the same. I will do the same because I remember two experiments of adding 2 stimulant equal 8 now. Yes. So let me add again. Let me add again. 2 stimulant every time. Then I will allow it to warm so that all the solid will dissolve. Yes, all the solid dissolve. After all the solid dissolve, now I will allow it to cool now. Okay? Yeah, the solid is still coming. They have not appeared. Crystals have not appeared yet. They are still to appear. Yeah, so this means there is a lot of water here. A lot of water. A lot of water of 8 centimeters of water with 1.6 grams of water. So it means now the solubility is very high. So that the salt is very difficult to form. It will take a lot of time. So you should be tolerating, or you should be patient on that. Don't hurry. As no, believe in haraka in apparatus. So don't hurry. So you just wait. You wait, so that you will get it. Yes. Don't run from the result. Just be. Still, okay? Work, yes, let us cool it so that it will form crystals. And make sure this water will not enter into the content. It can enter, should react. If it goes to the content, it will what? It will be a minus or a problem for you. So don't do that. Sorry, makakak no. Lakini wait, you just wait all so that crystals are going to form. Crystals are going to form. See now. Are you see now the solid started to form? Yes. That is why you will not hurry. The solids are going to form. The solid are going to form. Are you see now? Yes. So let's look the temperature now. Yeah, the solid form a temperature of 29. Okay. 29.0. These are points now. 0, 50, 40. So. Okay, the last but not the least. The last but not the least. So we measure 2 stimulant. Make sure you will measure only 2 stimulant. Don't measure 10. If you measure 10, it's like you will get an inaccurate result. Yeah, don't measure 2. Yani, measure 2 all the way. Along the way you measure 2. So 2 as 2 as. So measure 2. Okay. Measurement of 2. Remember, this is quantity. Quantity now. If you measure, if you have not measured exactly, it means you will get a fake result. Then it will be a means for you. Good. So, yes. Then again, now I'm working to that procedure of repeat all the procedure in 3 times and record the temperature in table below. Yani, yes. So I'm repeating. This means now I'm resolving all the solid now. Heat the solid until it dissolves. 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 Then allow it to cool. Heat the solid until it dissolves. Allow it to cool. Now it has. I have heated the solid. Good. Allow it to cool now. Allow it to cool. Let's form. Not yet. This one, it takes a lot of time. Remember, it contains 10 centiliters of water with 1.6 gram of the oxalic acid. I see now. So we have warmed. After warming, coming back, forming the crystals will be a lot of time. It will take a lot of time. Crystals are coming in a teeny way, but they will come. Don't worry. Have a peace. Don't cry. When the sun goes down, as your tears will not let you to see the stars in the sky. Don't cry, so it will come for you. Have hope and work together. Have hope. Yes, you are given a time. Take the time and you go. Take your time. Solubility was just a long time ago. This year, we are expecting it. We are expecting the solubility to be tested as a prediction. We're predicting it. So don't worry. So the candidate is you must be what? You must be confident yourself. Take your time. Be patient as you're waiting your good result. Good. It has 4. At a temperature of, so let's see the temperature. At a temperature of 23. Temperature of 23. Good. 23.0 now. Okay, let's go. Now let's complete the table by calculating the solubility of all the oxalic acid at different temperatures. Now I want to calculate the solubility at different temperatures. At this temperature, the solubility. At this temperature now, what is the solubility? That's what I want to calculate. Okay. Again, at this temperature, there were 2 centiliters of water is used. Therefore, solubility is equal to mass of the solute I was using, the oxalic acid, times the 100 divided by the volume of the solvent. Now, the solvent was the water. So therefore, at this solubility, I will say this is the centimeter cube, the volume of the water that was used, the volume of the solvent that I've used. And the gram was 1.6 6 grams alongside. So I will say what? I will say what now? If the solubility at that place, it will be 1.6 times the 100, because solubility should be in 100 grams by water, isn't it? Yes. Divide by the 2 centimeter because of it is here. So let's calculate that. Let me calculate. So 1.6 times 100 divided by 2. So that is 80. So I will go and write 80 here. 8. Yeah, 8 grams by 100 centimeter cube. Here is solubility now. Here is solubility. So 8 grams solubility in gram by 100 grams of water. So this is 80. So let's go now to this. Every time solubility is equal to 1.6 times the 100 divided by the first centimeter cube of water, because second experiment. So that is 1.6 times 100 1.6 times 100 divide 4. So that is, this is 40. Isn't it? Yeah. 1.6. Yeah, 1.6. I see now. 1.6 times 100 divide by 4. That is 1.6 times 100. So divide by 4. So that is 40. So the solubility at first centimeter cube at 40 degrees Celsius is 40. Again, solubility of the third experiment, that is 1.6 times 100 divided by 6. So that is 1.6 times 100 divided by 6. So 160 divided by 6 now. That is 26.66 now. So that is a 26.66. So you can make it 2. So that's 26.67. So last one, solubility at this number 8. So we'll say 1.6 times 100 divided by 8. So it will be 1.6 times 100 divided by 8. So 160 divided by 8. So that is 20 now. So that is 20.0. So that means the solubility is 20. The solubility when the temperature is 29, the solubility is 20. Okay, again the solubility are 10. So at 10, I will say 1.6, that is the mass, times, what with this formula? Times 100 divided by the 10. So that is what? 1.6 times 100 divided by 10. So that is 16 now. So that is 16. That is 16.0 gram. So this is now the solubility. This is now the temperature. I have filled my table. Then look here. NP, there is something that you need to know. NP, the solubility of a salt increases with the increase in temperature and decreases with the decrease in temperature. So it means now, I see now the solubility. The solubility is increasing. If I increase from 23 to 29, the solubility is increasing from 16 to 20. From 29 to 33, it is increasing from 20 to 26. From 40 to 50, it's increasing from 40 grams of water to 80. So I see now. So it means the solubility is increasing with the increase in temperature and decreasing with the decrease in temperature. So it means if I decrease the temperature, I see now. If I decrease the temperature, the solubility is going to decrease. So from 50 degrees Celsius, if I decrease the temperature from 50 to 40, the solubility is the ability of the cell to resolve will decrease from 80 to 40. From 33 to 29, it will decrease from 26 to 20. As you know, as goes. So that is now what you need to remember. Again, another point to note: cooling was allowing. When I was cooling, I was allowing the crystals form. Cooling allows the crystals to form, while warming was dissolving the crystals. When I was warming, the crystals were disappearing. I see now, disappearing. Like when I was cooling, the crystals were appearing. They were forming. So it means now, cooling and warming or heating, cooling forms the crystals. Warming and dissolves the crystals. So that is how you need to know the solubility. In fact, this is how it is done. So that was now about solubility. That was about solubility, which was very, very interesting lesson. And now that is how I fill my table, and that is how I explain the solubility. Again, and the lesson is continuing, and there is that questions and in the solubility. There is drawing of graph, reading the questions from the reading, and doing the questions from the graph, all that. So, inshallah, for the next lesson, I will be discussing with you that, and then I will again put those lessons or those calculations in the next lesson. So subscribe the video and share and like the video. Subscribe, share and like the video. Don't forget that, so that you will be able to notify all our videos. In fact, the green part, the best part is coming is the calculation and drawing of the graph. So I'm coming with those. So share the video and subscribe the video and then you like the video, then you comment. If there is any question or any inconvenience, you will write for us, or you will comment. You will write for us in the comment, and then inshallah we will rectify it. So with those few remarks, thank you very much. Have a very good evening, or good day, or good night to you. Thank you very much.